Welcome back to VTU e-Shikshana program on computer-aided engineering drawing. We are going to cover module 4, that is isometric projection today. Now we will take up basics of isometric projection. What exactly isometric projection? How to continue with this with different type of problems. Now let me take a simple model of the rectangular prism. This is the best model to discuss any item, for example projection, etc. Here also it is very important. I have two types of edges, shorter edge, longer edge, height for the prism. This is the top face, this is the base. Now let me have the corresponding projection. This you know very well now. The top view is rectangle of 50 by 25, assuming that the longer base edge is parallel to VP. Okay. Next, height is given as 80. Now we have to draw the isometric projection or view for this. What I will tell you the difference between view, drawing and projection. For right now, let us consider view. Okay. Now let me draw the isometric view for this. Now if you take up this particular figure, all sides are parallel, all base edges are parallel to HP or on HP, all longer edges are perpendicular to HP. Now let me draw the isometric view. In isometric view, all sides which are parallel to VP and perpendicular to VP and also perpendicular to HP, all are on either on 30-degree line or vertical line, none other than that. Only in case of standard solids I mean square prism and rectangular prism, and also for limiting case of square prism is cube. Okay, in these type of problems all the edges are on 30-degree lines or vertical lines. Now let me start working the isometric view of this. All lines which are on HP and parallel to VP are perpendicular to VP. There are two conditions: parallel to VP or perpendicular to VP, number one. Number two, on HP or parallel to HP. All these lines are on 30-degree lines. I will tell you after this figure, the completion of this figure and getting some idea about the isometric view, how exactly you are getting that. Now let me have two 30-degree lines, one starting from a reference point. Reference point now is A for me. Here is the nearest point to the observer. If you are looking from this direction, nearest point to you on the ground is A1. A1, B B1, C C1, D D1. Nearest point to you is A1 on the ground. Okay. Now let me mark that. Okay. Next, after this, to the left of the observer from A1, how much is this? 25. And this is 50. To the left, you mark 25, and to the right, you mark 50 on 30-degree line only. So this is 30-degree, 30-degree, and here how much I have to mark? 25. Okay, mark 25 mm. Assume that I am marking 20 because I am marking AD now, A1 D1 base edges, and then to the right of me it is 50, AB, A1 B1 base. Okay. Now I have covered two edges of the base. Now two edges of the base is A1 D1 and this is B1. Now I have to keep C1. Okay. This is A1 D1, A1 B1. Okay. I have covered D1 and B1. Yes. Next, I have to mark C1. Here, this one C1. Since the base is rectangle, in this case you will get parallelogram. How to get it? A1 B1 is parallel to C1 D1. A1 D1 is parallel to B1 C1. So draw two parallel lines, thin lines first. Draw two parallel lines through this. Yes, you get C1. Visibility concept, let us worry afterwards. Let us not worry now. After completing the base, that is, assume that this is dark surface, I have completed the isometric view of this, all around 30 because these are parallel to and perpendicular to VP and also all are on HP. That's why all are on 30 line. Now, all vertical lines remains as vertical, no change. So, draw vertical lines through this. C1, same length, that is height 80 mm. Whatever given, let us keep it. I am drawing isometric view. Okay, now keep this. That's all. Same height 80 mm. Then mark these points. D, this is A, this one is B, this one is C. Join all of them. Top corners, join. Thin lines. Okay. I have drawn light lines all the time. Repeat, all edges parallel to HP or on HP, number 1. Perpendicular to VP, parallel to VP. All are on 30 lines and vertical lines remains as vertical. I got this figure as isometric view. Now, if you look from this direction, base is not visible. The nearest key surface is top face. It is same as this projection of solids, key surface reference. Nearest surface is visible, boundary line is visible, base is not visible. So, let us do that job. So, keep all the visible edges. Key surface, visible key surface is top face, fine. Assuming that the height of the solid is below your eye level. If it is above eye level, you cannot see. That we will discuss. This is only simple. Visible key surface dark, boundary lines dark. Boundary lines dark. Yes. Then what about this line AA1? AA1 is visible because of vents. I hope by this time you understood. Or you can always interpret this invisible key. Let us not draw dotted line. In isometric view or projection, we never draw dotted line. This is not visible, this is not. That means the base surface is not visible. It is on the ground. This dark color, yellow color is not visible. So it is on the ground. So naturally, if you look from this direction, that is not visible. Invisible surface, visible line or bends or crossing line. This is invisible, definitely this is visible. So that's all about the isometric view of the given prism in P direction. If you look from this direction, suppose that somebody wants to look from this direction and draw the isometric. Yes, you can draw, very easy. Keep this way, definitely look from this direction. Again, top face is visible, base is not visible, but the nearest corner on the ground for the observer is B1, not A1. So let us draw the isometric projection for this. So this is B1, is nearest point to the observer on the ground is this, that is the point. Okay, now let me keep this way. Yes, draw 30-degree line, 30-degree line. Okay, now to the left of the observer from B1 to A1 it is 50. To the right of the observer it is 25. Here in this direction 25, 50. So keep 25, 50. Okay. 25, 50. Yes. This side 25 and this one is 20, 50. Draw this. Next, this is A1, this one is C1. Then draw parallels. Then project. All vertical lines remains as vertical. Now join all this. Yes. Now we have the overall figure. Now how to complete this figure? Top face visible, dark. Dark top face. Yes. Boundary is visible. Yes, boundary is visible. Then base is not visible. If base is not visible, this edge is visible. That is bends or crossing line. Invisible line, invisible surface, visible line. Here it is bends. Now leave the invisible lines as is. So this is how you get in this. This is referred to as D1. This is A. This one is B. This is C. This is D. Same figure I have in different direction. So this is how you draw isometric projection or view. What is the difference between isometric projection and view? So isometric view, isometric projection. This is isometric view or isometric drawing. Okay. So isometric view is nothing but draw as though you are working on isometric projection using actual distances, that is view or drawing. Isometric projection you draw according to the procedure, that is reduced length. Now I will take up, to explain this, I will take up a simple solid which we already worked out in projection of solids. In particular problem we had the problem of the solid diagonal is parallel to HP and perpendicular to, like this or like this. Yeah, let me keep it like this. This is solid diagonal. It is joining top corner with the base opposite corner or body diagonal. In this case, if I take up this solid diagonal is perpendicular to VP, parallel to HP. Now, if you look from this direction, this particular top face is square, appears as rhombus. Now I have drawn this figure for reference. Already we worked out. This is the figure. So this is top face of the cube when you have the one of the body diagonal, that is PC in bracket. See this is ABCD PQRS. If you have PC perpendicular to VP and parallel to HP, you will get that figure. Now let me name that point. This is, say this is A, this is A, this is B, this one is C, this is D. This is P, Q or S. For explanation sake I am doing it. Now let me draw a line horizontal. If we measure this distance, definitely this angle, definitely it is 30. This is also 30, this is also 30. And also here we have 120 degree from this particular corner, 120 degree, 120 degree. So this is referred to as isometric axis. This is the basis for isometric projection. Okay. These three lines are referred to as isometric axis. These three lines are making 120 degree each other. Same. Iso means same. That is why it is called isometric projection. Isometric projection of a cube is this. Okay. Now you measure any face edges angle or base edges angle, all are 30 degree, and vertical lines remains as vertical, no change. This is the standard solid for clear explanation of isometric projection. Now I will take up this figure, this model, to explain the what is called the isometric scale. Now this is the top face of the cube. Okay, when the top face is parallel to HP, when it is resting on HP like this. Okay. Now, when you get this particular position, that is solid diagonal is parallel to VP and perpendicular to HP, that will be inclined to some angle, so that this figure is going to give a rhombus, And again you observe AC in first position, okay, and second position say. AC distance never changes. About AC only it is rotating and gives you the rhombus. So rhombus is the isometric projection of square, provided this particular distance never changes. Only this will change. Okay, how much will change? We will discuss here. This is in the same figure. Let me discuss. Now, after getting this idea, let me concentrate only on the top face. Let me draw the top face. Okay, this is say A, this one is B. For explanation purpose, I am changing it. ABCD is the isometric projection of the top face. When it is having the body diagonal perpendicular to EP and parallel to HP. When it is parallel to HP like this, in this corner condition say, in this condition ABCD, that is the figure. In this condition AC never changes distance, AC remains same. Through that I have to draw 45-degree line. So then you will get the actual distance, true length of the sides. Green line edges are giving true length of the sides. Black color lines are giving isometric lengths. So let me consider these two lines only now. Before that, let me measure this distance. This angle is 30, this angle is 45. Now let me have small AB as the ABCD as the top view, because we always use ABCD top view. Now draw two lines. Again, starting from a point, fixed point, say this is P. Okay, let me draw two lines. One 30-degree line, other one is 45-degree line. Now fix this distance AB. Say this is 50 mm side, 50 mm side. Okay, let me take this as A, B. This is capital A, capital B. As per this figure only. This line I have considered, and this line starting from a point with a horizontal line. 30-degree line I have drawn, 45-degree line. Now this is actual length. This is actual distance. Actual length. This one is actual length. This is isometric length. Now we will repeat. If this is the case, this is top view, small ABCD, top view. Okay, assume that this I have taken, little bit zoomed one, say this one. Now if I make it like this, that becomes rhombus, but AC is fixed in that case. Now I am taking different. AC is fixed. This is AB, small AB. This is capital A. Sorry, this is A only. This is A. This one is B. D, T, yes. Now, if you take this actual length and isometric length, you can easily draw isometric scale to any length, 1 centimeter, 10 centimeter, or any number of units. So, let me draw a general isometric scale. On 45-degree line, you fix actual 1, 2, 3, 4, 5, 6, 7, 8, up to 10, say. Any number, any value you can take. 1, 2, 3, in centimeters, say. 8, 9, 10. Now, with respect to 30-degree line, draw verticals, not perpendicular or anything, particularly vertical lines. If it is horizontal, then it is vertical. Then these distances are giving you isometric values of corresponding distances. Say this is a tandem I take, isometric 7 centimeter, okay, isometric 10 centimeter, like that. Suppose that you have this problem, how many you want? 25, 50 and 80. So draw two lines, 45-degree and 30, and fix only these points. I want 25 mm, 50 mm and 80 mm. This is 80, 50 and 25. Corresponding values you get. This is how you generate isometric scale. So using isometric scale, if you draw these figures, that is called isometric projection. If you take direct values and draw isometric projection, then it is called isometric viewer drawing. But in case of sphere, there is a unique procedure, exception. For sphere, you don't have isometric view. That is projection only. I will explain that when I start working the problems on spheres. Now, after this, to draw isometric projection effectively, you should know minimum of 4 or 5 figures, minimum 3 figures. You can say square, rectangle and circle. If you know that, you can definitely work any problem on isometric. Then derived one, pentagon, hexagon, triangle, etc. you can do. Now, let me start working for square, and before that, let me draw isometric projection of this figure using isometric scale. Okay, already I have drawn the scale, then I will draw this one. Okay, now by the side only I draw so that you will get the difference. Okay, now let me start from A only, A direction. This is A1. Instead of taking actual distance 25, you take isometric 25. Say this distance you take. Okay, now let me take up, this is the actual and this is isometric. Okay, now isometric distance I will take. So 30 degree line. Similarly, instead of 50, you take isometric 50. Draw parallels. This becomes D1, this is B1, this is C1. That's all. Now, draw verticals. Isometric length you take from this distance, from scale. Yes, draw. Now just observe, here this is A, B, C, D. The size has been reduced to a smaller one. So how much it has been reduced? So if you take up this 10 centimeter or 10 mm, 10 centimeter, 100 mm, 100 mm length, so that will reduce to some value. Okay, that value will give. Okay, 8.165. Okay, 81.65 value you will get. So you always take from this, or you can calculate and do it. If you calculate, you will get the decimals. Better always take from the sketch. But in computer, you have very good tool. It is called scale. You first draw isometric projection, then scale it. That's all. But while scaling the sphere or hemisphere, then you must be very careful. Now, this is what the difference between isometric projection and isometric view. Using actual length, you draw figures as per the isometric procedure. You get isometric viewer drawing. If you get foreshortening of the distances, for example, this one I keep AC. This one AC. This is A. This is C. Then true lengths, always true length. Then if you reduce it, these lengths will become foreshortening. That is reduced length. That reduction of length is to be considered to draw the isometric projection. Now, let us start working 3 basic figures to continue with the isometric projection, that is the square, rectangle and circular lamina. Okay, then easy to continue with the isometric projection. Different procedures, different problems. Okay. Now, let me have rectangle as the reference. Yes, lamina. This is A, B, C, D. This is top view of the arrangement, I can say. Don't worry about the front view. Top view of the arrangement. All are parallel to all are parallel to VP and perpendicular to VP. Standard solids, standard laminae. What are standard laminae? Standard this one, square and rectangle. These two are only standard things, and then all are different type of procedures you have to follow. Okay. Now, how to draw the isometric projection of this? First, I draw isometric projection only because you have to get feeling of isometric projection. Draw a line. Assume that I am looking at this object from A direction. Keep A. Now, this is say 30 and this one is 60 or 50. 30, 50. To the left of you, 30 mm on 30 degree line. Always see that it is on 30 degree line, and on one more 30 degree line to the right, 50. This is D, this one is B. Draw. Already to explain this, I explained it. Easy to understand now. So this is how you draw the isometric projection of a rectangle. In this direction, you start from B and other way around you get it. That's all. The advantage is, if you draw these two, you draw parallels to these two through B and D. Parallelogram, easy. Okay. So that means isometric projection of a rectangle is parallelogram. Number one. Number two, isometric projection of a square. Assume that this particular square is having two sides parallel, two sides perpendicular to HP. So assume that again this is top view of the arrangement XY. Yes, XY, VP, HP and all is available. Assume that it is available now. XY, VP, HP. This is VP, HP. And forget about the front view, but concentrating only on the top view. Now, this is A, B, C, D. Say 40 mm square. 40 mm square. Yes. How to draw the isometric projection of a square? Yes. This is A. Fine. Either side you have to draw 40 mm, 40 mm to the left and to the right. Yes. Assume that I have drawn this 50, 40, 40. Then draw parallels to these two already drawn. How to do it? With compass, you take same distance, draw 2 arcs. Definitely you get it. But please verify whether you got this point. This is B, sorry, this is D, this is B, this one is C. C is exactly on a on this vertical line through A. If this is the case, then wrong. Now see that this is doing it. But I have a better procedure than this, because you have to draw 30 degree line and see that these two are parallel, then this joining, etc. I have a better method already. You might have learned from your middle school and high school classes. Your teacher might have told, for any particular rhombus, this is rhombus, isometric projection of a square is rhombus. Minor axis is this. The sides of the rhombus is always equal to the sides of the rhombus. This minor axis, AC equal to AB, AD, CD and CB. What you do is draw plus mark. I am repeating, be careful, take this procedure, it works well for you, for anybody for that matter. Draw plus mark. Plus mark is best mark in graphics. Take compass. Assume that I am taking compass. You take the side equal to 40. You take 20 mm, half of the distance, half of the 20 mm, radius, draw arcs. So assume that I am taking 20 mm radius and drawing arcs. Okay, drawing arcs with compass. Then take total. This is how you draw this. You got AC ready. Then take total. Don't lift the compass. Draw towards either side. That's all. If you lift the compass, then there is a tendency to move to this point and draw arcs. This is the most dangerous point here. Okay. So don't lift the compass. Take half, that is 20-20. Take total length from either from A or C. Draw towards either side. Definitely you get rhombus, that is exactly the asymmetric position of a square. So if you are doing manually, okay, if you are doing it manually, but in computer it's easy, you can do, create and check, do it. But manually if you are doing, within no time you can complete this job. I will repeat, draw plus mark, take half of the square side, 20 mm, 20 mm, get AC, need not name it always, get two ends of the minor axis, minor diagonal, not axis, minor diagonal, and then take total, mark both sides either from C, A as center or C as, not from the center. Okay. If you do it from the center, it will go somewhere. It is not the asymmetry. So with this, you can complete isometric position of a square. Now finally, I have one particular very important laminae, that is circular laminae. So if you have circular laminae, I always say standard solid, standard laminae, square or rectangle. It is neither square or rectangle, but we can enclose this with a square. Okay, this is box method. We can use box method and do it. Any other shapes other than square and rectangle, you have to use box method. This also use box. Assume that I have a circle and I have covered, I have enclosed that in the square box. Yes. Now you know how to draw the isometric projection of a square, because if it is 50 dia, 50 square, then you know 25-25, take this as center, draw arcs, you will get within no time this particular figure. It is very interesting, very easy also. Now, what is the procedure to complete the isometric projection of a circle? Mark midpoints, because it is smooth curve. You never have corner or edge. Okay. So this is the procedure. This is called 4 centers method. This is called 4 centers method. How to get those 4 centers and radii, what are the radii to do it? Yes, it's very easy and easy to understand. Let me name these points as MN, PQ. For explanation purpose, you need not have to do anything. Just identify those points and then proceed. Now, join midpoints of the sides with opposite corner. I will repeat, minor diagonal corners as reference, you identify midpoints of the opposite sides. MN, PQ, MN with A, PQ with C. That's all. Then I will just equate some of the values here. Say MA equal to, not, let me name, after this, let me name points, 4 points. Keep this as 1, this is 2, coinciding with A and C. This point as 3 and this point as 4. These are the 4 centers we have to complete the isometric projection of a or view of the circle. Now, M1 equal to N1, that is also equal to P2, that is also equal to Q2. Yes, Q2. This, let me be small letter. Yes. 2P equal to 2Q, that's also equal to 1M, 1Q. Let me identify this as capital R. Then 3P equal to 3M, that is also equal to 4N, that is also equal to 4Q. That is small r. 1M, 1N, it's also equal to 2P, 2Q, capital R. Then small r is nothing but 3 to 4. Now, this 75% of the work is over, only 25% is left out. What is that? 1s center, capital R equal to radius, draw R. 2s center, again same capital R equal to radius, draw R. Two segments of ellipse. You get isometric projection of a rectangle is parallelogram. Isometric projection of a square is rhombus. Isometric projection of this circle is always ellipse. Suppose that I keep diagonal diameter line here like this and then rotate as we did for the cube, you will get ellipse as the apparent view. Okay, apparent shape as ellipse. So this is isometric projection of this ellipse, circle as ellipse. These two segments. After that, you must be very careful. 3 and 4s center, small r equal to radius, draw arcs. You will get perfect ellipse. But there is some problem in completing the hemisphere, but let us not worry about it. Majority of the time you use it. But the very problem people face, sometimes you get some shape which is of some baseball or something like that. What is the problem people face? They take this distance 3m or 3p and take this as center as the reference and draw. Center is the most dangerous point now, as I told there. Here also same problem. Here also people face. Or otherwise what they do is they take 3 to center point and draw the figure. They will get like this. This is wrong. This is correct. 3 and 4s centers, small m, or here only it's available, 3m, 3p, 4n, 4p. There only you take and draw, but don't touch this. This is more dangerous point. So you will get like this. You never get ellipse. You will get something else. So these three are very important. Now we will work out the same on computer and then proceed further. Take up isometric projection basics. Okay, let me take up isometric projections basics. We have rectangular prism or cuboid, it is also referred as cuboid, with two parallel sides, base sides are parallel to VP and our two shattered edges are perpendicular to VP. In this position, you know how to draw the orthographic projection. So have top view, so A1A, B1B, C1C, D1D representing. This is the pictorial view. I am going to tell you what exactly this. Okay. Now, the longer edges and front view actually is the largest, the rectangle surface you can see. Otherwise, you cannot see anything. So, you will get this is the front view. Now, how to draw the isometric view? I already told you what is isometric view, isometric projection. If you take actual distances and draw the isometric projection type procedure, use isometric projection procedure, that is called view or drawing. Otherwise, if you use scale and do it, that is projection. Now, let me start working. Assume that you are looking from A, which is the nearest corner you can see on the ground is A1. So, to the left of you have 30, to the right of you have 60. Here it is 60, 30 and right is 100. Now, after you get 30 and 60 either side, so to the left of you it is 30, to the right of you it is 60 on 30 lines only. Then you draw parallelogram using parallel lines. That we will discuss how to do it. Now draw vertical lines. All vertical lines remains as vertical. All horizontal lines are parallel to the ground or 30-degree lines. Only in case of square and solid, that is again condition is either parallel to or perpendicular to VP. That is possible only in case of square and rectangle. In case of pentagon, hexagon and all, we have many sides and they are inclined to their adjacents itself. Now, draw vertical lines and then join them. This is in the direction of P. Nearest point is A1. In the direction of Q, B1 is the nearest point on the ground. See, B1 is the nearest point on the ground. Then to the left of B1, we have 60. To the right of B1, it is 30. Draw these things on 30-degree lines and then draw parallel lines and get intersection as D1. Then draw verticals from all the corners 100 mm and join them. So this is how you get. Now the visibility consent, now I have this finally. So dark it, visible top surface, and then boundary lines dark, and this is bends or invisible surface, visible line. Here also same argument. This is isometric views again, direction of the direction Q. Now, what is isometric projection? What is the projection concept? I told here we have solved a problem in case of solids when the cube has one of its solid diagonal, that is PC, parallel to HP and perpendicular to. This is the final front view, final top view. This is the one which I have taken as reference and to discuss. See, the top face is square actually, that has become rhombus, but BD is constant, no change with BD. We were tilting about BD so that the front view appears as rhombus. So that is what the overall figure of isometric projection of a cube. Now I will take this as a reference and discuss. Now this one I have enlarged to 2 times so that you can see easily. This is the isometric projection. Actually this I am taking as reference of isometric projection of a cube. So why it is called iso? See, this axis here, this one, okay, CB, CD, CR, all are equally inclined to each other, 120 degree each other. So that's why it is same, that is iso. That's why it is called isometric projection. Other projections are trimetric. In general, it is called axonometric. Okay. So here it is the case I have taken top face, and also capital ABCD represents the actual, actual say, and the small ABCD represents the isometric. Now, let me concentrate on these 2 lines, AB, A dash, B dash, AB and A dash, B dash. This is inclined at 45 degree if you measure. This is inclined at 30 degree. So draw 2 lines inclined at 30 degree and 45 degree from the same point. This is actual length, this becomes isometric length. So now you just observe, I have taken out the top face only and then identified AB capitals and A dash, B dash front view. So assume that it is front view because I have drawn from front view. Now, so assume that this is AB, this is small ab. This is projection, either top view or front view. Here it is front view. Now, this is actual, this is isometric. AB, actual length, isometric is this. How to draw? Draw 45 degree line, 30 degree line from a point and fix 50, 60, 70 up to 100. Even you can take 10, 20, 30, 40 and draw verticals. You will get corresponding isometric lengths in the scale which is on 30 degree line, which is on 45 degree line, actual lengths. So actual length, isometric length. So that is isometric scale, actual scale. This is actual scale, this is isometric scale. So to simplify, I have given exclusively the particular scale. Isometric length is this as the actual length. So isometric length equal to 0.8165 the actual length. So you actually measure this and divide this with the actual, you will get 0.816. So this is how you get isometric scale. Whenever you are working for the isometric projection, length is isometric, height is isometric, width is isometric, thickness is isometric, you are isometric, I am isometric. Everything is isometric except one thing, that is isometric projection of sphere or hemisphere. So that sort of things are different because irrespective of the direction, front view, top view, you look at sphere, all the time you get the true circle, that is true length as diameter or radius, you have to draw a circle as the projection, irrespective, just like a point projection. You look from any direction, you will get a point, something like that only. It is sphere of true diameter, you have to draw it, but to fix the height, you have to fix the isometric heights, height of the center of sphere, etc. Okay, otherwise actual sphere dimension is 2 lengths. Now, how to draw isometric projection of a square, rectangle, etc. Now, I told you how to differentiate between the isometric view or drawing and isometric projection. This is using actual lengths, say actual 60 and actual 30 you used. Here it is isometric scale you have used, reduced lengths according to this figure, this length. So you can take 10, 20, 30, 40 and do it. Otherwise, you just multiply it by this, you will get values. So this is how you can differentiate between view or drawing and the projection. Projection is the figure drawn using isometric scale, reduced scale. Now, as I told you earlier, how to draw the isometric projection of the square, rectangle and circle. Now, for all practical purpose, I draw isometric view. So, assume that you are drawing projection, I am keeping view because it is easy for me to explain with the actual. Otherwise, you have to radiate it, reduce and do it. You can do at home. So, practice it. Now, so as I told, here I am looking at this in this direction. Nearest point is A for me. On a parallel line, on a horizontal line, you fix A, and then to the left of you or left of the A, you have 40 mm, draw 40 mm, and then to the right it is 60. If it is isometric projection, reduce lengths. Next, draw two parallel lines to this. This is very easy in computer. See, just take line and touch this and move. You will get a parallel symbol. Okay, you will get parallel symbol. This one, and again, this one is to be see, parallel is not there. It is switched off. So you keep it on. Then say OK. That's why it is not coming. You see that all are available. Into the sketch, take line, and then touch this and move. See, now I am getting parallel. So keep. Don't fix to a specific dimension. Then you can trim easily. Now to this line you draw parallel. That means we are working on parallelogram. That's all. See, here you take this trim and trim this. Then what is this point? It is C. So this is how you draw isometric projection of a rectangle. Now how to draw isometric projection of a square? See, this is square. You look from P, look from A. You look from P, A is the nearest point. You draw either side, same distance, say 60 or 50, same distance. And then draw two parallels to this already drawn and check whether you have done properly. Draw vertical line and horizontal line. On vertical line, 2 corners you must have. On horizontal line, 2 more corners you must have. And all are on 30 line. So I will show you how to do it, very easy. So let me do that. Have a line. See that this is thin line always. Yes, thin line and normal line. Now start from a point. Normally if you draw a line, it will show the midline. Okay, you can take that only and fix the 2 lines at random. Okay, 2 lines at random. Then you can even measure and fix the angle also, no problem. Then take this, I want say 50, yes. Again this also I want 50 because this is square. Now you see that both are on 30-degree line, yes. When drawing only you keep 30, no problem, but keep this. I am seeing the possibilities. Now keep this. Even after that you have to measure, check it. So 30. Now these two are fixed. On 30 line I have fixed 50, 50 either side. So now I don't want any dimension to proceed. So keep this out. Now draw 2 parallel lines. So but do it very patiently. End of the line, touch this and move, yes. Small changes, yes. Then at the end of the line, touch this and move, Yes. Now check. At the end, if you check, then problem starts. At the beginning only you should check. We have experienced it now. Yes, this is correct. And this is again check. This is how you have to work out. At the beginning only you have to check. If there is any problem, you rectify and wait, because this is not the only problem you have. This is the only basics. So with this we have connected things many. Okay, we may have fresh term of square pyramid or combination, many things. Now this is how you draw the isometric projection of a square. Isometric projection of a square is always rhombus with these two angles 120 degree, these two angles 60 degree. With the horizontal, all the lines are 30 degree. Okay. So now, how to draw the isometric projection of a circle? As I told you earlier, the circle is not having any edge or corner. We cannot do it, and also we cannot consider this the standard solid or laminate. You have to go for box method. Other than square and rectangle, always you use box method, including circular laminate. Okay, for that I have enclosed a box, then this it is actually square of side equal to diameter. Now you know how to draw the isometric position of a square, that already I have drawn. Now what is the procedure? Four centers method. How to identify the four centers method? Now you have to check these sides, midpoints of the sides connect to opposite. Now I will do it. Okay, we'll do that job now. See, draw lines joining corners with opposite midpoints of the opposite sides. That is the procedure. Do it carefully. Now again take this corner and opposite sides, midpoints. Automatically you will get into the sketch, you will take care of that. Suppose if you switch on, switch off, then problem. If you have switched off, then it never works. Sometimes this midpoint reference creates you problem, then you switch off. Now again, let me draw a line, see that all are intact. See, this is yes joining horizontal line. Need a draw, just check it, yes. This is also giving proper, yes. Now, better you draw this line, because that I need. Okay, because two centers you get, already two centers are ready. These two are centers. Now, what to do? MN, PQ. All these four lines are equal, and also from center of this and this distance are equal. Now you take this arc method, arc, CS center or one or two centers, draw arc. Two segments you can complete with this. See, yeah. Then with this as center, A as center, you not name all the time. Just for reference, I am giving MN, PQ, etc. These two segments you can complete. Now, take these 2 points. So purposefully I have not drawn vertical line. Normally I draw vertical line to check and retain. But majority of the time people take this point, center point as a reference, and this distance as radius and draw an arc. Okay, it is wrong. So purposefully I have not drawn this vertical line. These two are two more centers. So this is center and this distance, that is joining the midpoints to this point as center. Draw arc. Again take this point, then draw arc. That's all. This is how you get the ellipse. Sorry, it is not completed. See, sometimes we keep the gap. So better you check twice before you proceed. Now let me zoom it and then do arc by center point. Take this center point, intersection. Yes, this is distance end point. Yes, completed. End point reference should come. Now this is ellipse. Now dark this. Select all this if you are interested. If you need it. Otherwise, the procedure may not require that has to be dark line. So leave as such. Part of the ellipse only is required as dark line. Now dark that for explanation purpose. Now this is left out. You can again select and then dark it. So this is how you get. Now I will give the procedure for again you draw the symmetric projection or drawing of a square, okay. Then identify the midpoints and join that with the corners, and for explanation purpose I have named MN and PQ 1, 2, 3, 4 as centers, 4 centers method. Now this is segments, 2 segments you draw with 2 as center and 1 as center to cover PQ and MN segments. Then see I have written 1 and 2 as centers, R as radius, draw arc segments PQ and MN, and 3 and 4 as centers, draw arc segments PM and PN. So they will get. Now I draw first using this reference. Then I draw 2 more. Yes. Then you get complete. Okay. This is how you draw 1, 2, 3, 4 centers with the respective radii. Draw and complete. The isometric projection of a circle is always ellipse. Now sometimes people end up with this. See, they take this as center and MN blindly and do it. It is more like a baseball or some different thing than ellipse. So always avoid this type of wrong, procedures. Stick to the actual procedure and complete, and see that it is ellipse. Measure axis, or even check that with the, but initially you can check with the ellipse command. See, I will take any ellipse command and check whether it is intact. Okay, see, go to ellipse by 3 points, take this point and this point. Okay, then see, I am getting ellipse and coinciding, that will coincide. Okay, so definitely you will check this, but you cannot check all the time. Okay, better you enlarge and zoom it and then check. Otherwise, in this type of this one wrong procedures definitely will come to light if you check that. You only can recognize this is not a regular shape, this is odd shape. Okay, so this is how you can work out the problems on isometric. This is only basics. Based on this, you are going to develop. See, this is a rectangle. I can develop prism, pyramid, and frustum of rectangular pyramid and block. Like that, you have many more. We will discuss that at length. How to prepare all this. Okay. So here is triangular item. Correspondingly, you get prism, etc. So like that, we are going to have this pentagonal prism, pentagonal pyramid, block, and pyramid. So like that, you have many more. See, hexagonal prism, block, and frustum of hexagonal pyramid, and hexagonal pyramid itself. So how to do this, we will discuss at length in next coming sessions. And here I was telling about the isometric position of a sphere is always true radius, but to fix the center of the radius, you must take isometric distance. This is frustum. There is a question. A sphere is centrally placed on frustum of a hexagonal pyramid. That we will discuss at length in coming sessions.